Hi everyone! It's time to tackle the last exercise in this section, where we're going to play with Json decoder, which is a generic trait. This is the first time we'll be working with traits together. So far we have only implemented case classes and functions. So a trait is basically an interface where we can define abstract methods. In our case, Json decoder has only one unimplemented method called decode, which lets us parse a JSON document into a value of type A. For the sake of simplicity, I've used a string to represent a JSON document here. So the goals for this exercise are to keep practicing the design of a functional API, and at the same time to learn the specifics of working with traits in Scala. So let's have a look at a few examples. Here we have a JSON decoder of int that uses the toInt method from the string API to convert a JSON value into an int. Note that if the string is not a number, it will throw an exception. And here we have a JSON decoder of string that checks whether the text starts and ends with double quotes. If it does, we remove those quotes, otherwise we'll throw an exception. So to create a JSON decoder, we need to say new JSON decoder, and then we need to specify the type between brackets, so long, for example. Then we need to define decode for that particular type. So I'll say JSON of type JSON, and it will return a long. So as you can see, traits are more tedious to define than case classes. But IDEs often support some forms of completion. Here, for example, we can ask IntelliJ to generate the signature of all unimplemented methods. So we'll remove this decode, and we'll do Control N, implement, and we can say here, and it will generate all the unimplemented method. Here we only have one. So you might remember from the val versus def lecture that JSON decoder is a special kind of trait called a SAM type, which stands for Single Abstract Method. Indeed, JSON decoder has only one unimplemented method, decode. And whenever we have a SAM type, we can drastically shorten its implementation with the SAM syntax, like this. Which syntax you prefer using is very subjective. Just one thing to keep in mind is that if you plan to extend your interface later on, it is better to stick to the standard object creation syntax, like new JSON decoder, because it will minimize the potential code change if a second method were to be added to the interface in the future. Okay, so first we're going to implement a JSON decoder for user ID, a case class that I define here. This is a simple wrapper around an int, and we create it to avoid the common mistake of putting the wrong data in a field expecting a user ID, for example, the user's age. So now please pause the video and have a go at implementing and testing this JSON decoder. So first let's try with the standard object creation syntax, like new JSON decoder of user ID. Then we'll generate the decode method. So first what we want to do is to convert the JSON into an int using json.toInt. And we want to wrap this int into a user ID. Now instead of using toInt, we might want to reuse in decoder the JSON decoder of int that's defined above. So we could say int decoder.decode here. It's a bit more verbose, but in the future we might want to change our JSON representation to something more accurate. So it's better to have the parsing logic from JSON to integers in only one location. Okay, so now how do we test this JSON decoder? As usual, we can write a couple of test examples. So we could say user ID decoder.decode, and if we pass the string 1, 2, 3, 4, we would expect to get back a user ID 1, 2, 3, 4. Let's convert this into an assertion. Then we might also want to test with a negative number just to check that the negative sign is parsed properly. Now the question is, how do we check that it fails if the JSON value is not a number? The problem is that we expect an exception to be thrown. So in that situation, what we can do is to use try from the standard library. So we could say try, and whatever we put within a try will be caught by try. So we'll say user ID decoder, decode hello. And now if an exception is triggered here, try will catch it. And then we can ask try if it's a failure or a success. So we can say is failure. Let's run the tests. Okay, all good. Now what about property-based testing? Can you think of a property for user ID decoder? I'll let you pause the video and try it out. So what we can do here is call the round trip property. So we'll basically duplicate this test and call it user ID round trip. And the idea behind it is to generate a random number. So this will be an int. And then we'll convert this number into a JSON using toString, so say number.toString. Then we call user ID decoder and we decode this random JSON. And we would expect to get back a user ID containing the random number. Let's run the test. So as you can see, it's called the round trip property because we start from one value and then we serialize and deserialize it, expecting to get the same value back. This property is very generic and it can be used for any form of serialization, such as JSON, CSV, Avro, you name it. Okay, now let's come back to the exercises. And this time we're going to implement a local date decoder, a JSON decoder for local date. So here we expect a date with a format year-month-day. So for example, if we pass the string 2020-03-26, we expect to get back the date 26th of March 2020. One thing to keep in mind is that we want this date to be a JSON string, meaning that it must start and end with double quotes. So please pause the video and try it out. So this time, let's try the same syntax for a change. So first we want to define the input JSON, so we'll say JSON. Then we put an arrow, and here we need to write the parsing logic. So the first thing we want to do is to check and remove the double quotes in the JSON value. So let's reuse the logic from string decoder as we don't want to repeat ourselves. So we'll say string decoder.decode JSON. And this will give us a date in a string format, right? Then we need to verify that the resulting string has a right date format. Fortunately for us, local date has a parsing function called localDate.parse. So we can say localDate.parse, and here we need to pass a datetime formatter from the JavaTime package. This can contain many standard prepared date formats, and it allows us to create custom ones if needed. So in our case, we want to parse our date string using the datetime formatter ISO local date. And we can verify in the documentation that it is the right format here. Okay, now how do we test it? Well, as we did before, we can write a couple of test examples. So we can say local date decoder. If we want to decode, what is it? Or maybe let's copy paste the examples over here. It might be faster. Okay. So here we want to assert that this specific string is equal to local date March 2026. And here we want to verify that we got an exception. So we can use, again, try to capture to safely call this function, and it will capture if there is an exception and then check that a failure occurs. And then we can duplicate it for hello. Cool. Let's run the test. All good. Now let's try to apply the same strategy we did before using the round trip property. So now let's copy paste this code and write the round trip property for local date. So here it's going to be a local date of type local date. We convert it into a JSON using the datetime formatter. So this datetime formatter works both ways, it parses and also formats. So we can say format local date. Now we don't want to use a user ID decoder, we want to use a local date decoder, and at the end we want to verify that we get back the local date. Cool. So let's run the test. Actually it didn't compile, and the compiler tells us that it cannot find an implicit value for an arbitrary of local date. This error is quite obscure, especially when you're new to Scala. Scala check, the library we use for property-based testing, needs to know how to generate random inputs for a test. We've seen that Scala check knows how to generate values for common types, like ints, strings, or lists. But it seems that it doesn't know how to generate local dates. So is Scala check hard-coded for certain types, or is something else going on here? It turns out that the library uses a generic type called arbitrary, which is basically a random generator for values of a particular type. So for example, if we want a test that generates random integers, we need to give for all an arbitrary of int. But wait a minute, we haven't passed any values to for all. It seems that somehow the library figured it out on its own. In fact, in Scala, we can pass arguments explicitly or implicitly. We are used to doing it explicitly. This is when we put the arguments between parentheses. Doing it implicitly, however, means that it is the compiler that is passing the arguments, rather than us. So passing arguments implicitly may be simpler, but the mechanics behind it are much more complex. For example, there are intricate rules that determine where the compiler looks for these values, and here the compiler is telling us that it couldn't find such a value for local date. Now the good thing is, we can define custom random generators ourselves, so let's make one for local date. So the first step is to create an implicit value of type arbitrary local date. Like this. And we can see that now our code compiled. The red squiggly disappeared. If I remove the implicit keyword, it will not compile anymore. So the implicit keyword is really important here. It's what allows for all to find this value implicitly. So now we need to replace the triple question mark with a real arbitrary implementation. For this, we can use the arbitrary constructor. So we can say this. And here we need to pass a value of type gen_t, so gen local date in our case. So let's define one. So we'll say van gen local date. So gen is kind of the real random generator, while arbitrary is just a wrapper we can use to fetch gen implicitly. This is because we may want several random generators for one type, for example, a random generator for alphanumeric characters, or one for the Japanese alphabet. The problem is that we can't have two implicit values for the same type, because when the compiler looks for an implicit, it needs to do it without our input. So it must only have one option. It's a bit more complicated than that, but it's a good overview of how implicits work. So to create a random generator for local date, we can leverage the fact that the local date is just a long number that represents how many days have passed since the epoch day, which, as you probably know, is the 1st of January 1970, which is used as a point of reference for many date operations. So for example, we can say local date of epoch day. So if I say of epoch day 5, this will be 5 days after the epoch day. Now the only thing we need to be careful of, and I've been burned by that before, is that we need to pass a number that is not too big or too small. Otherwise we'll get back a runtime exception, as we can see in the documentation. So it says if the epoch day exceeds the supported date range, we get a datetime exception. So we need to generate random values within a certain range. And we are in luck. The gen class has a method for this. It's called gen.choose. So we can say gen.choose, and here we need to pass the min and max value for the long numbers that we want to generate. And for this, we can look at local date, which contains two constants, min and max. So we can say min 2 epoch day, local date max 2 epoch day. So this will generate a gen of long. So now we need to convert this gen of long into a gen of local date, and we can do it using the map function on gen. So we can say map local date of epoch day. That's it. So let's run the test and see if it works. I didn't. Ah, okay, interesting. So the problem here is that I forgot to, the encoding of the JSON string is actually wrong, because if you remember, we need the JSON to start and end with double quotes. So we need to say here, we need to escape double quotes, and we need to do the same thing at the end. Okay, so let's run the test again, and now this time it works. Okay, so now another point I wanted to mention is that we have actually two options with regard to random generators. We can use them implicitly like we did for all. Now it fetched this arbitrary implicitly. We didn't have to put it here. Or we can do it explicitly using specifying the gen method, the gen object we want to use. And let's run it again. So it's really up to you which approach you prefer. Personally, I prefer to be explicit. Yes, it's a bit more verbose, but it's also clearer this way. There is no implicit magic, and anyway, we have to use this approach when we want to use a different random generator than the standard one. For example, if we want a property for positive numbers, like we saw in the first section, we cannot use the implicit generator because it produces both positive and negative numbers by default. Okay, now let's come back to the exercises. And as you can see, both user ID decoder and local date decoder are really similar. They both reuse an existing parser and then apply a transformation to the decoded value. For instance, a user ID decoder decodes the JSON into an int, and then it wraps this number into a user ID. And local date decoder first decodes the JSON into a string, and then it uses a datetime formatter to parse it into a local date. So there is a pattern here, and we are going to capture it with the function map, which by now you should be familiar with. So I'll let you pause the video and try to implement map, and then use it to simplify the implementation of user ID decoder and local date decoder. So let's define the JSON input. Then we have an arrow. And now we need to return a value of type 2. How do we get this value? Well, we somehow have to call the update function. And for this, we need a value of type from. How do we get a value of type from? We need to call the decoder decode method, and for this we need a value of type JSON, which is the input of our function. So as you can see, it's pretty straightforward to implement once we get used to manipulating generic types. Now let's refactor user ID decoder and local date decoder using map. So now our user ID decoder is going to be map of int decoder, and the update function is going to be the user ID constructor, while local date decoder is going to be map of string decoder. And what's going to be our update function? It will be local date.parse, where we pass the string and we use the datetime formatter that we had before. Cool. So as you can see, it's really worth doing because it simplifies the implementation, but even more importantly, other developers who read this code will now have a very clear idea of what is going on. We have to remember that the code is written once, but read many times by different people. So we should always aim to write programs that are easy to understand. Now the question is, can we move map inside of JSON decoder? That way we would be able to use a more object-oriented syntax like int decoder.map instead of map int decoder. So I'll let you pause the video and try it out. Okay, so let's create a map method in our JSON decoder trait. So we'll say def map. It takes a type parameter 2 and an update function from A to 2. And it's going to produce a JSON decoder of 2. Let's create an anonymous JSON decoder here of type 2. And let's ask IntelliJ to implement the decode method. So what we want to do is to say update on decode JSON. This was a previous implementation that we had. Let's make it compile. So it doesn't work, and IntelliJ is telling us that it expected a type A and it found a type 2. So actually what happened is when we call decode, it's equivalent to this.decode. And this represents the anonymous instance of JSON decoders that we are creating for map. So it means that we are accidentally doing a recursive call here. And we can tell because of this snail symbol on the left-hand side of the method's name. So the question is, how can we call the decode method from the author object? We could try to capture the reference of the author this in a variable and then call decode on this. So something like that. Val author equal this. And then use this variable here. This is a technique that you may be familiar with if you come from JavaScript. So let's make it compile. It still doesn't work. But the problem here is that author is a member of the JSON decoder interface. So when we create a new JSON decoder, it has its own version of author. So we're back to square one. How do we get hold of the author reference? It turns out that there is a special syntax in Scala for this particular situation. We can add author arrow next to the class name, and now this time it does capture the this value of this author reference. So this is sometimes called a self-type or self-reference syntax. But what it does is just creating an alias for this so we can use it within a nested instance like here. Cool, so now let's refactor the JSON decoder instances with this new object-oriented syntax for map. So now we can say int decoder is going to be int map like that. And local date decoder is going to be string decoder.map like this. Much better, isn't it? Okay, so now we're going to work on the last question for the day. And it's going to involve some API design. So you might find it more difficult. So imagine we have to integrate with a JSON API that is a bit weird, as it is often the case in the real world. So this API sometimes uses a string to encode a date, like 2020-03-26, as we saw earlier today. And sometimes it uses a JSON number that represents the number of days since the epoch. So we might get a number or we might get a string. We don't know. But in both cases, we want to parse it into a local date. So now please pause the video and try to implement such a decoder. and if possible, try to think how we could extend the JSON decoder API so that we can easily build other decoders like it. Okay, so let's create a new JSON decoder for local date. And what do we want to do is we want to first call the standard local date decoder that we had before. So we'll say local date decoder decode JSON. If it succeeds, we keep the result. If it fails, we want to fall back and try to parse it as a number. So how do we do this? Well, we need to use try, as we saw before, to capture an exception if it occurs. And let's create a variable for this. So let's say attempt. So this will be our first attempt at decoding. And here we need some kind of if then else. So we say if attempt is successful, so if it's a success, then we want to unwrap it. So we'll say attempt.get, which will give us a local date. Otherwise, we do fall back to the number decoding. So we'll say JSON too long, because we remember that the epoch day was represented as a long number. And then we'll say local date of epoch day. So this may throw an exception, but that's okay, because if both decoder fails, we want to throw an exception. Okay, so here it probably works. Let's write a couple of tests, for example. So let's open our test file, and we can basically actually copy this property-based testing here that we created for local dates. So we can say, let's generate a random local date. Let's parse it into a JSON. So this will be our weird local date decoder, and it should work. So it should at least behave in the same way as the normal local date decoder, and it does. And we should also verify that if we encode the date as, so let's call it JSON1 and JSON2, as a number, it should work as well. So if we say local date to epoch day to string, in both cases, we expect to get the same local date back. Okay, it works, great. So now let's come back to our code and let's try to see how we could refactor it. So the first problem I find here is our call to attempt.get, because it's kind of a code smell, because get may throw an exception if the try is actually an error. Now, here it's completely safe because we did a check that it is a success beforehand. But it's dangerous to still code get because the code is going to evolve, someone is going to refactor it, and we may arrive at a point where we don't have an if statement before this get. So it will be better, in this case, it's better to use pattern matching. Try is actually an enumeration. It's either a success or a failure. And every time you have an enumeration, pattern matching is the best option. So we can say attempt match, and we say case, if it's a success, then we have access to the date that is inside it. And if it's a failure, we have access to the exception that was thrown. So here we can say if it's a success, we keep it, we keep the date. If it's a failure, we fall back to this parsing. Make sense? Okay, here we can remove the exception because we don't use it. So here now it's better because this date here, we will be never in a case where we try to extract data from a try that is an error. So we can't have this error anymore. Okay, one thing that annoys me a bit here is that we kind of hard code how to decode JSON from a long number. This ideally should be a JSON decoder on its own. So let's create one. We can say val long local date decoder, long JSON decoder this will be a JSON decoder of long, and the implementation is going to be very straightforward. We can just say too long. So here is the equivalent to do JSON here using the SAM syntax, but we can even make it even shorter like this. Okay, so this is one point. We could actually here do local date, sorry, long JSON decoder.decode and do this. And it should still work. Yes, it does. Okay, actually what we could do also is to create a local date decoder that uses a long encoding. So we could say long local date decoder, long local date JSON decoder, and this will be a long JSON decoder where we map it using a local date of epoch day, right? So now we can use this JSON decoder here what did I do wrong? Ah, yeah, actually this is not a long, this will be a local date, right? Because we map it. Okay, it compiles, and if we run it, it works. Okay, so we haven't changed anything so far. We just extracted some basic building blocks. But by doing so, we kind of discovered a pattern here. What we are trying is we basically have a situation when we try one decoder. If it succeeds, we keep it. If it fails, we try another one. And both of them are of the same type. This pattern is generally called get or else or else. And let's try to add a method to local date decoder for this. So we could copy-paste this code and go to the JSON decoder interface and add this or else method here. So this is going to be, this is going to take another JSON decoder. So this will be other JSON decoder of A, and it's going to produce a new JSON decoder of A. Because in our case, we had two JSON decoders of local dates, and by using or else, we create a third JSON decoder of local dates. And let's copy-paste the code. Except that it's going to be a JSON decoder of A, it's going to return an A, and here we don't want to try local date decoder. This is equivalent to outer. We want to try the first JSON decoder. Then if it succeeds, it's going to give us a value. It's not a date. We don't really know what it is. It's an A. And if it fails, we want to try the other JSON decoder. Perfect. So as we can see, this pattern is completely generic. And now that we have it, we can refactor weird local date decoder to be long local date decoder or else local date decoder. So we try one, or maybe this was actually the same code that we had before. It doesn't really matter. It doesn't really matter which one we try first, because anyways they are completely, they try completely different things. Or maybe it does impact the exception we get at the end. One thing we could do also here is, because or else is a method that takes only one argument, so we can use this infix operator syntax. So we don't have to put dot and parentheses, which I think it reads quite well. Okay, so I think this was a good exercise of API design. We're starting by implementing a custom JSON decoder for this unusual local date encoding. Then we realized that nothing in our code was really specific to dates. We had a completely generic pattern of trying one decoder, and if it didn't work, we would fall back on another JSON decoder. So we captured this pattern using or else, and then it was very straightforward to implement this custom logic. Now, even more importantly, everyone who reads our code is likely to understand what it does at first sight. Now, if you're feeling extra motivated, I've also created more exercises for JSON decoder that I will not cover in this video. But as always, you can find the answers and tests in the answers folder over here. So in this exercise, we had a good overview of how to implement traits in Scala, using both the standard object creation and some syntaxes. We also discussed the round-trip property, which is a really useful testing strategy for all serialization APIs. This was also the occasion to learn how to create custom random generators, as well as introducing the concept of implicits. So it was pretty intense, but I hope you have enjoyed these long coding sessions today, and that you start feeling more comfortable working with parametric APIs. They can be quite intimidating at first, as we don't know the value of the actual types we're dealing with. But as we saw today, it's actually really useful, because we have to treat those values as black boxes, meaning that when we test generic functions, we know that they will behave exactly the same for all types. And as a result, we get better test coverage, even though we write fewer tests. So it's time to take a break before the next section. See you soon.